Hello! Today we're going to dive into one of the most important reactions in all of chemistry, neutralization. You can think of it as a kind of chemical balancing act. It happens all around us, and we're going to break down exactly what's going on behind the scenes.
So you've probably heard that when an acid and a base mix, they just cancel each other out. But what does that actually mean? What's happening on a level so small we can't see it? That's the real question we're going to answer today.
Okay, let's start with the official definition. At its core, neutralization is simply a chemical reaction that happens between an acid and a base. Now, there's a really important word here, exothermic. All that means is that this reaction releases energy, and it does so in the form of heat. So if you were holding a beaker where this was happening, you'd actually feel it get warm.
All right, to really get what's going on, we need to zoom in, way in. We have to look past the liquid in the beaker and think about the individual atoms and ions, because that's where the real action is happening.
It all boils down to a four-step process. First, when you put an acid in water, it releases positively charged hydrogen ions. That's the H+ you see here. Second, a base, specifically an alkali, does something similar, but it releases negatively charged hydroxide ions, or OH-. Now you know what happens with positive and negative charges, right? They're powerfully attracted to each other. And that leads to the final step. They combine. The H+ and the OH- snap together to form a perfectly stable and electrically neutral water molecule, H2O.
And this is the ionic equation that shows exactly what we just described. This is the heart of every single neutralization reaction. It doesn't matter if you're using strong hydrochloric acid or weak vinegar, a powerful base or a mild one. Deep down, this exact reaction, a hydrogen ion meeting a hydroxide ion to make water, is what's driving the whole process. It's the engine of neutralization.
Okay, so we've established that water is always one of the products. But what about the other parts of the acid and base molecules? They don't just vanish, they form something else. In fact, every neutralization reaction gives us two very predictable products.
So, product number one is always water, H2O. We know that comes from the H+ and OH- ions. Product number two is what we call a salt. And what is a salt? Well, it's an ionic compound that's made from the leftover bits of the acid and the base that weren't the hydrogen or hydroxide ions.
Now, this is a super important point, so let's pause here. When you hear the word salt, you're probably thinking of the white stuff you put on your food, right? That's sodium chloride, NaC. But in chemistry, the word salt means something much broader. It refers to the entire family of compounds that are formed in this way. So things like copper sulfate or potassium nitrate, they are also salts, chemically speaking, even though you would never eat them. Okay, so the main story is always acid plus base gives you salt plus water. But there are a few interesting twists to the plot depending on the exact type of base you use. Let's look at three main variations you'll encounter. This table lays it out pretty clearly. Look at the first two types of bases, a metal hydroxide and a metal oxide. When they react with an acid, the products are exactly what we expect, salt and water. Simple. But now look at that third row. This is the interesting one. If your base is a metal carbonate, you get a surprise. You still get your salt and your water, but you get a third product too, carbon dioxide gas.
And this is something you can actually see. The production of that carbon dioxide gas isn't quiet. It shows up as fizzing, as bubbling. It's quite dramatic. This is a fantastic clue for a chemist. If you add an acid to some unknown white powder and it starts fizzing like crazy, you can be pretty sure you're dealing with a metal carbonate. It's a perfect example of how an equation on paper connects to a real observable event in the lab.
All right, let's wrap this up and review the most important things to remember about neutralization.
So here are your key takeaways. First, acids and bases neutralize each other in a reaction that gives off heat. It's exothermic. Second, the real chemistry is always H+ ions plus OH- ions coming together to make water. Third, every single time you're going to produce water and some kind of salt. And finally, don't forget the special case. If you use a metal carbonate, you get that extra product, carbon dioxide gas, which you'll see as fizzing.
And that brings us to a final, pretty interesting question to think about. We know this reaction always releases heat. It's always exothermic. So could we ever use that? Could we harness the heat from neutralization reactions on a massive scale to generate useful energy? It's a fascinating idea to ponder. Thanks for joining me today.